Hi, friends. Thank you. See, that's what I needed, that energy from that one person back there who cared. No, it's too late. I don't want your pity. I appreciate you, though. Thank you. It's so nice when lots of people come to a great conference. And can we just give a big hand for the organizers of GOTO for putting on such a beautiful, beautiful conference? Absolutely one of the top conferences, not just in Europe, but worldwide. Much better than the last conference that I was at. It was me and that one guy had a good time, but it was good. So my name is Scott Hanselman. You might know me from my podcast. If you don't, you should check it out. It's a great show. I've done over 500 episodes now, so that's 10 years of podcasting. It's not Microsoft specific. It's a non-denominational podcast. I've got another one that I do with Rob Connery called This Developer's Life that people are always asking about. We are working on another episode, so you can check that out. And I've also got a website called March is for Makers that I do every March with my friend Saran from Code Newbies, and we talk about IoT and stuff like that. So if you're interested in IoT, check out marchisformakers.com. Super fun, lots of great stuff. Now, as said before, I do work for Microsoft. But I work remotely. So I'm on the forest moon of Endor, safely outside the tractor beam. And I work in open source, right, which is great. Now, when I went to work at Microsoft, I came from open source, right? And I work on opensource.net, and I work on the cloud. People called me a sellout. They said, you're selling out to the big corporate machine. And it really hurt my feelings. It made me really sad, and I didn't know how that I was going to be able to deal with that and get through that situation. But somehow I found the internal strength, the personal integrity, because there was a time before Microsoft when, things were kind of rough for me. That's me on the left there. But after Microsoft, things worked out pretty great, And working at Microsoft is a little bit rough because we have a pretty complicated org chart at the Microsoft. It's funny because it's true. But what I want to talk to you here is not about Microsoft, but rather about the cloud and the browser. I was at Intel recently, and I was talking to a person there who was very, very old. And I mean like 120, 125, talking about super old. This was like employee number 12. And this was a person who had seen my talk on web programming and asked me how they could become a web developer. And I thought that was really awkward because this is someone who has forgotten more about software than I'll ever know. And they're asking me how they can learn about the web. And then I realized that here's a computer science person, a low-level microcode assembly language person who's been in the industry for 50, 60 years, but they missed out on the web stuff, all the nested tables and the one-pixel transparent GIFs, right? All the crappy parts of the internet. Just to give you a sense of how old this person was, this is a picture of them taking a selfie. This is a very, very old person. This is the kind of person who can look at some Lisp and be like, oh, you missed a parentheses right there. And then they would put the parentheses back, just the right number of parentheses, right? This was a person that was so old that I was like, what were you doing when you were not on the internet? And they were like, oh, I'm sorry, I missed that. I was too busy inventing the compiler. That's the level that we're talking about here, okay? Now, So I thought to myself, what an opportunity here to teach someone who is a computer person today's internet and skip all the yucky stuff, right? Well, I said, okay, let's look at it in two ways. There's the cloud, and then there's the browser. We'll start with the cloud. Now, there was a time when this Thomas J. Watson, who I guess was the head of IBM or something, said that they thought that there was a world market for maybe 5 computers. They would figure there'd be like 1 per continent. And I guess maybe England probably would want their own, so they would have their own. But there was basically a refrigerator-sized computer, 1 per continent. Once you sold all 5 computers, that would be the end of it. Now, I don't know if this is a real person. I don't know if this is a real quote. But I do have this really old book. So we'll just make that the guy. Because, Abraham Lincoln said that you can't trust quotes on the internet. So if I'm going to be making up all the quotes in this talk, we're just going to start with this random guy. All right. So it turns out that this is actually true. There is, in fact, 5 computers, right? There's like the Google computer, and then the Azure computer, and then there's like the bookstore computer. I like to imagine the Microsoft executives like, how are we losing to a bookstore? And they like slam their hands to the ground. But that's just how I imagine it in my mind. This is a picture of the Azure cloud. We're upgrading, right? We've got color, which is cool. We're constantly adding new, fresh computers to the Azure cloud. So don't count us out yet. He's pretty happy. Well, that's there we go. He's pretty happy about the Azure cloud. But I said to the person at Intel, I said, all right, well, there's this thing called the cloud. And the person at Intel said, well, is that what hipsters call hosting? I was like, well, yeah, but no. It's more than just, hey, there's a computer that I can't see anymore. That's what they thought the cloud was, right? Before, you have a host, and it's like, oh, it's that one. Right? It's that Linux computer. And then the cloud is when you just take it away and then you say it's in the other room somewhere. We don't know where that is, right? That's what the cloud is. But the cloud is more than that. What I said was the fundamental idea was when we started to have virtualization. Now this is a diagram here that you see in school when you take your computer science courses, and it's the characteristics of an operating system, right? Here's the stuff that makes up an operating system. You have to have security, you have to have memory management, you have to have networking. If you have all that stuff, you have an operating system. And I said this to the person at Intel, and they said, yes, I know, I invented all of that. And that was super awkward, but I was moving through that. That's what happens when you talk to 120-year-old computer people. Well, I said the power isn't the operating system and the hardware, it's the lie. It's the idea that I can lie to that machine and make it virtual, that I can carry it in a USB key in my pocket, and the computer doesn't know it's being lied to. It doesn't know it lives in the matrix, right? It lives in a virtual machine, and it can be then moved from the cloud to my data center to other locations. That's what the power of virtualization is. And in fact, if you think about virtualization, if you've all seen the movie Inception, right? That's a movie about when you run a virtual machine inside another virtual machine, time slows down, right? That's the message that D'Onofrio is trying to get to us. Now, you can do anything in a virtual machine, and when you put it in the cloud, it's even more amazing. You can do things like run Linux in Azure. In Azure, actually, 30% of Azure is Linux. People don't realize that. And they say, how would they allow that? How is that okay? Why would they allow? Well, what do you think it's running on? It's running on Windows. Whee! We're going to make you use Windows no matter what. So, and you can go up to somewhere like VM Depot, which is this cool website with all these open source virtual machines. And you can say, hey, I want, this Jenkins virtual machine that runs on Ubuntu. And I can go and grab that little bit of information and say Azure VM create, and I can programmatically talk to that virtual machine. The programmaticability, is that a word? Programmaticness? Being able to programmatically create a virtual machine is the power. So I asked the person in Intel, how do you make a virtual machine today? And they said, well, you fill out a form and you fax it to your manager. And then a couple of weeks later, a virtual machine gets provisioned for you. That's horrible. Like, you need to be able to go like that and say, create a virtual machine, and you'll get some ASCII art, which is awesome, because, you know, that's how Microsoft tells you that we're not evil anymore. Just lots of ASCII art and stuff. But virtual machines are kind of complicated. I don't really like virtual machines. I'm not a huge fan of virtual machines. Virtual machines are free like a puppy. It's like, hey, free puppy, great, cool. Now you have to run apt-get update on the puppy and apt-get upgrade, and no one wants to have to do that to a puppy. It's no fun. When you get a virtual machine, you're now responsible for that thing, right? You have to manage the life cycle of that virtual machine from that moment on. What you manage the operating system, you manage the apps. So while the person at Intel was thinking, oh, I can just make virtual machines in the cloud, that's cool. I said, well, if you want to put like an expense reporting application in the cloud, you don't want to think about the virtual machine. Like if there is a Heartbleed or another one of those cool named bugs that comes out for Linux, they always have the best names. And then you have to go and shush into a machine. Do you all shush into your machines? I'm trying to make this turn into a thing. I want that to be a thing. We don't SSH into machines. We shush into them. And you have to do the little thing when you do that. Now, for your coworkers that didn't come to GOTO, I want you to just spend a couple of days just casually just fitting that into conversation. I don't know how it works in Danish, but you just shush in. And then get it so they think that that's a thing now, and then they start saying that. Then you switch back like nothing ever happened, and then see if we can turn that into a thing that people say. Okay, so, you know, you have to go and shush into the machine and then update it and stuff like that. And you can do anything with a virtual machine. It's great, but is that the layer of abstraction that you want to be? It's kind of like, you know, your first car, where you have to learn how to drive stick shift, right? You have to learn how to drive manual. I know that in America, most people don't know how to do that. Not only do most Americans not have a passport, but most Americans can't drive a manual stick car. Is this a manual stick country or automatic? Manual. Good. Because in America, if you break your leg and then they need to drive you to the hospital, you have to find someone who can drive manual or you're going to lose the leg. That's like a real problem in America. This is why we teach people assembly language first. You make them suffer. You make them hurt. You tell us, hey, you want to learn computers, kid? Move AX, comma, 0. It's going to be great. And then after you're done and they've suffered enough, you say, no, C. C is so much better. Why did you make? Don't worry about assembly. We're going to learn C now. And then you make them suffer in C, and you malloc and you free and you malloc a couple more times, and you don't free. And then you go, oh no, C++. It's like plus better than C. It's over here. Come on, it's great. Right? And then you teach them Java and C# and garbage collection and all that kind of stuff, and then you make them wonder, why did you make them suffer? Because you've got to suffer first. Because if computers were easy, then anybody would do it, and we can't have that. So virtual machines are like your first car. You can't go and get a rental car until you've learned how to manage your own car. And platform as a service, which are web applications, which is what the person at Intel wanted to do, those are like the Uber or a limousine, where you don't even have to change the oil. You want the cloud to manage the operating system updates for you. You don't want to shush into that machine or run Windows Update, right? Windows Update sucks. Having to remote into a machine to run Windows Update is really no fun. Have you ever had that experience when you're typing on your Windows machine and everything's cool and then time slows down and gravity starts to grab your hand, which was about to press enter? But as that's happening, the Windows Update restart dialog is coming up. And you don't know how to stop it, and the Restart Now button is the default button. And you're like, no. But your hand is already being drugged down to press thing. And then Windows is like, we're restarting. And you're like, no. And there's only one way to stop a Windows machine that has had that happen, right? And it's a dirty notepad. And then Windows, the power of Windows and the Intel Pentium processor, like, not responding. I can't reboot because Notepad is dirty. There's nothing, we have to save this text file or we are never going to be able to reboot this server. There's no other scenario. It's extremely painful. I don't want that experience. It's not okay. So you want to think about things at a higher level. The cloud isn't just unlimited virtual machines. The cloud is best practices, and the cloud is web applications. If I want that expense reporting app, I want to put it in the cloud. And this is where, as an old person, it becomes very painful for me. Because in the 90s, the late 90s, I spent about 10 years learning how to make what is called a web farm. Yeah, it's pretty amazing. He understands that. There was actually an entire page of my CV dedicated to scaling web farms. I'm one of the people who has a multi-page CV because I'm fancy. And page 2 was a decade of learning how to scale websites. And it is now a slider bar. And now I have the joy of going to work with young people who are like, oh, this website is taking like a minute to scale. Bleh. That's my impression of a young person. I'm sorry, I don't know how to do that. But you have to understand what it feels like when someone goes to the command line and they say site scale, and that line right there, updating a server farm, the 90s were wasted. Like you lost a decade of your life. But remember, we're trying to teach this to the Intel person who skipped out on that stuff. So we're not worried about my personal pain and the lost decade scaling server farms. What we're interested in is the fact that that slider bar is the true encapsulation of a best practice. Your insurance company or your healthcare company or your whatever magical startup you work for, whatever unique snowflake that your company is that has text boxes over data with a new JavaScript way of doing it, the root issue here is that scaling a web system is pretty much understood. So the cloud has gone and encapsulated those best practices for geographic load balancing and things like that. And it's all just done for you. So I can go in there and scale, and people are like, what just happened? Magic. So I told the gentleman from Intel, like, you don't have to worry about that anymore. It's understood. The best practices of my decade have now been encapsulated into a checkbox, and it's okay. So then he says, well, what language should I use? Do I have to use C#? Do I have to use Java? What do I do? I said, well, a good cloud doesn't care about language choice. Pick whatever language makes you happy. It's totally cool. And he couldn't believe that, and he became a little bit lightheaded. He can run .NET or Node or PHP or not PHP or Python, or just whatever makes him happy. It's all open source and it's great. And it all lives up in the cloud. Now, this is at such a high level of abstraction. It sometimes can be difficult to get one's brain around. And the best story that I have about this is actually a GOTO conference story. I was at GOTO. And we were getting to see Adrian Cockcroft, who was at the time the chief architect of Netflix. Okay, he looked like this guy, and he's English, which means he gets +2 charisma just immediately upon arriving, right? And he's the chief architect of Netflix, which is like amazing, right? So then he shows up and he's explaining how Netflix made some really interesting architectural decisions in the cloud. High-level decisions, above virtual machines, above web apps. The decision was whether they should go from spinning Rust hard drives you can hear, right? If you can hear your hard drive, you're probably a bad person and you should get an SSD. Buy an SSD. If you can hear your neighbor's hard drive, don't ever trust them. Hard drives are meant to be silent. Or how do they transfer those from spinning Rust over to SSDs? So they were looking at what's called IOPS, right? The cloud has this notion of input operations per second. It's some number that the cloud uses to indicate throughput from an I/O perspective. And it was something like, Amazon was going to charge them $1 for 300 IOPS or $3 for 6,000. It was like 20 times the perf for 3 times the money. And he was explaining this at a high level, and then they just had to like push a button and it would work, and it was amazing. And he talked about the whole architecture and how it was great, but the simple decision of X times more money for 20X times more perf, awesome. SSDs are great. At the end, they did the Q&A. And this young Danish individual came up. I don't know how to do a Danish accent, but I can do nerd. And they were like, well, actually, sir, SSDs are extremely unreliable, and they will probably fail, and started basically telling the chief architect, British guy, +2 charisma, of Netflix, PhD in unsolvable numbers, who knows, telling him, you're an idiot. SSDs are going to fail, and you bet your company on them. And how do you justify that? It was unbelievable. And he just stood there and just took it. It was unbelievable. And he thought about it for a second, and he said, that's not my problem. I'm renting them. We didn't know what to do. I wanted to just slap somebody. I didn't know. I just felt This kid didn't even know he'd been cut. You know in the ninja movies when the shunk, and then the head has been cut like this, and then the top part of the skull and the brain just falls down, and the brain is like right there, and the person's like, do I push him over? Is he going to fall on his own? We didn't know. He didn't know he was dead. That's not my problem. I'm renting them. Whose problem is it? Amazon's problem. What if they all fail? Still not my problem. Right? They have an architecture that they can deal with those kind of things, but ultimately, if you rent the car and the car doesn't run, what do you want to do? You want to have another car drive up alongside you, and then you jump into that car, and then this one bursts into flames and goes off the side of the road, and you just keep taking off, right? Because that's how rental cars work. Right? That's how it's supposed to be done. Now, I don't have an animated GIF of a ninja cutting someone's head off like that. And I apologize that I don't have that GIF. But I do have this GIF. That happened at GOTO. Like, that's the kind of quality technical discourse that you only get at the GOTO branded conference. That's the high level that they're talking about. When you're running something like a Netflix or a large company like that, and you're the chief cloud architect of something like that, you're looking at things at a much higher level dashboard. Do you really want to be shushing into machines in order to see what's going on? No, you want to see a map of the earth. You know what I mean? If you're a global startup like I am, with offices all over the world in every Starbucks, your company's dashboard has to include a map of the earth with random dots pushed on it, right? And you want a dashboard that's going to show you dollars and charts and graphs and all that kind of crap. You know what I mean? And if you're really into dashboards, that's cool too, But you can't fool yourself into thinking that that's a dashboard. And people still argue that that's a dashboard. Hey, man, I got a dashboard. I got a cloud right there. I got top. All right, fine, I'll upgrade. H-top. It's got color. You can't argue that that's a cloud-level dashboard, right? Those are the kinds of arguments that people can make, but they're always going to be wrong. You can't tell me that Mario is the superior Mario brother. It's always been Luigi. You can say Mario all you want, but I'm still not going to listen to you because no, Luigi. Just want to make sure you're paying attention. When you're thinking about things at a higher level, you also want to try to solve problems at a higher level so that things don't become a lot of what are called yak shaving. You guys know what yak shaving is? We'll talk about yak shaving in just a second. There was an interesting problem that the New York Times had where they had terabytes and terabytes of TIFF files that were scans, high-res scans of all the different issues of the paper. And they gave them to some interns, and they said, would you OCR these and put them into PDFs and have the embedded text so we can search them? Cool, no problem. Totally awesome intern thing to do, right? For each paper in papers, right? No problem. For loop, got that. Computer science, for loop. Well, it turns out that if you take, 150 terabytes of something and you for loop over it, it'll take a little while. So then suddenly, this becomes an interesting computer science problem when your boss is thinking, hey, for loop, no problem, maybe a weekend. But you're thinking, well, I could do multiple processors, multiple disks, I could shard the disks, I could have multi-threaded within the multiple processors. How many machines do I have? Suddenly, this is a really complicated thing. And your boss says, is that done yet? And you say, hang on, I'm trying to shave this yak. And when I'm done shaving the yak, then I will talk to you about the business problem. Yak shaving, you know what a yak is, right? It's a big hairy animal, right? Yak shaving is all of the stuff you have to do to get ready to do the stuff that you want to do. Right? Hey, I can put in a Node app in the cloud. Well, you got to get up your GitHub and you get your CI and your test containers and got to shave this yak. Let me show you a good example of yak shaving. Now, be careful if you go out there and you decide to Google with Bing for yak shaving. You can find some pretty bad stuff. So you're going to want to search for very specific GIF here. This is an animated GIF showing yak shaving. So this guy, Brian Cranston, comes home and he says, hey, how's it going? I'm turning my light on. Oh, this light is broken. I got to fix this light. Looks like it's burned out. Shoot. Oh, the thing is broken there. I want to fix that. The squeaky. This is kind of squeaky right here. Well, hang on. I'll get some oil for that. Oh, crap. I'm out of oil. All right. I'll go to the car and the car won't start. Oh, crap. All right. Have you fixed that light bulb yet? What does it look like I'm doing? Isn't that like every continuous integration server setup that you've ever done? It's like literally everything. That is how it's done. Oop, and then I've gone and lost my spot. That is tragic, because there's 7,000 slides here. You think I'm joking. There's like a freaking million slides. It's okay, there's only like 250 slides, so it's okay. We'll just look at Mario again. All right. So what if you could think about things at a higher level and you could do naive parallelism on something like that, right? You say, I want to do a for loop, and you just want to move the slider bar. The computer science problem of doing multiprocessor, multi-node, whatever type scaling has been solved. And now we're starting to see things like Amazon Lambda or Azure Functions, where you can write a little bit of code and you give them your credit card and you just say scale until $300, because that's how much money I have. That slider bar then gets plugged directly into your credit card and it will scale. And the problem is ultimately some function called doit that does that thing. Here's an example. You can imagine how to go and call a couple of libraries, an OCR, some text. It's not a big deal. But what if you could go and take that doit function in a little console app like this and put some inputs and outputs on it such that you have a trigger where you put a file into a piece of storage or into a queue, and it fires off that function. And then the resulting output pops into an output queue. Suddenly then all the yak shaving goes away. That's the promise of what is on top of platform as a service, where you can have functions as a service. So I try to explain to the individual at Intel that this is the kinds of layers of abstraction that we're seeing now with the cloud, and it's so much more than just hosting. So then we got to move to the browser. Talk about the back end. How do I explain the front end to this person? Well, remember this diagram where we have memory management and threading and all the different characteristics of an operating system. There was a time when you would sit down in front of a computer that looked like that, and you would talk to one of the 5 computers in the world that looked like a refrigerator. And you would go to your page, and you would go and there we go. And you'd go to your page, and that user interface was generated, though, by the refrigerator. What was that computer doing? It's waiting. Fast forward 40 years, and I have a quad processor, 16 gigs of RAM, i7 with SSD that's pretty much waiting around for angle brackets or curly braces pretty much all the time. I have a pocket supercomputer with a quad processor and 3D accelerated graphics that also waits for some refrigerator somewhere to go and make some text. I don't think that's what Tim Berners-Lee and friends wanted. When they made the first web page, by the way, this is in fact the first web page. This is like the beginning of the internet. And it's funny that your URLs in your website seem to change and get broken, but the internet's first page is still there, because cool URIs do not change. This page here was the beginning of the internet, and they had anticipated it would be this big hypermedia book. They weren't thinking application platform. They weren't thinking, this is going to be great, and then we're going to make an Angular JavaScript framework. They just wanted to have these infinite books, right? And Berners-Lee is a super nice person and extremely humble. And I think that we as developers and as web developers need to take a moment and appreciate his job title, because he could have put the. But he showed restraint, and he did not say the, which means that whatever your job title is, it's fancier than his is. So that means that I am not a senior web developer anymore. I will always be junior as long as that is his title. And funny story, actually, very uncomfortable thing that happened at work. I was talking to this very nice, I think it was a Danish guy, very nice guy at work, and we were having an argument about REST and HTTP, and it was a friendly argument, and then he left. And then my buddy says, "Do you know who that was?" Nothing good ever happens out of a sentence that starts with, "Do you know who that was?" No, tell me. That was Heinrich Nielsen. He invented HTTP. I was just arguing about HTTP with the person that invented it. I then double-checked, trust but verify. I went and looked on the spec, first name, Heinrich Frisk Nielsen. He was Tim Berners-Lee's intern. So now I see him in the hallways. I don't know what to do. What do I genuflect? Do I go like this? Like, he made a good job on the internet. Thanks, sir. They didn't understand when they made these things how popular they were going to be. And they didn't know that we were going to create hacks when we didn't get the web that we wanted. We wanted a portable document format. HTML wasn't the format that we wanted, so they made PDF. And the people that made PDF, they didn't know that it was going to become the 5th most popular religion on the planet. No one could possibly guess that. How could that have happened? So we're surfing the web, we're trying to make it something that it's not, and then this happens. How did we know when this happened? Because we were surfing, and then Java loaded. And then these guys were like, we can do it too, whee! Right? And then these guys were like, we've got YouTube. There's still a reason to live, whee! What were we doing? What were those three things trying to do? They were trying to do that. They were trying to bring another operating system. We wanted an application platform, so we put one in a little square in the middle of the browser, and then people would load applications up into that thing, and we thought it was a good idea. Now, you're all software people, so I assume when you go to check in at the airport that you want to see what's on the other side, because you're looking at their stuff. Hey, I'd like to check in right now. What kind of a system are you running here? Yeah. So how do I get upgraded? And then by the time you get yourself over here, you're like, oh, so F7 gets me to business class. Because we just want to know how that system works, right? Now, I've got a Toyota Prius. It's like a hybrid, because I live in Portland, Oregon, and they give us those when we're born. And I went to the Toyota store because I wanted to have the oil changed in the car, and I always talk to the guy about the system. They've got like a text terminal thing that talks to an AS400. And then one day I show up, and they got a whole new system. I'm like, oh, dude, you got to tell me about your new system. That sounds amazing. And he says, yeah, man, it's super cool. Fires up Windows XP. And then he fires up Firefox, and then he opens a jar file off the desktop, and Java's like, are you sure you want to run Java? And then he's like, yes. And then Java's like, the internet's pretty much decided that Java's a bad idea. Please type, the internet has pretty much decided that Java's a bad idea in this text box to prove that you know what you're doing. And he goes and he does that, and he loads the jar file, and the jar file is a terminal emulator that's talking to the same AS400 on the back end. And then he looks me in the face and tells me that this is so much better than the system before. We're creating these ridiculous systems that are these documents with these little islands of interactivity and little physics demos of teapots and such. And it's totally not what the world meant. And, you know, God bless Java on the server side, but for applets, it's more like write once, debug anywhere. Now, Java's happening, but then what's happening simultaneously? This is. Java people don't like that because it's totally not related. It's 2016, I'm still explaining to my boss that JavaScript doesn't equal Java, and I lose him somewhere at the exclamation point equal, and he's like, what is the exclamation point? I'm like, no, it just means that it's not the same thing. Just shut up. So JavaScript is happening, and JavaScript, it looks like it could be something. It could be amazing. Here is a flow chart of what it's like to work in JavaScript. JavaScript. So how did we know that JavaScript was amazing? It's because people did crazy stuff with it. They built like terminal emulators in JavaScript. They built Commodore 64 complete system emulators in JavaScript to prove that it was possible. But we all thought it was a toy, right? Because we would always have these conversations with our boss about whether or not we should use JavaScript for stuff. But do you remember that moment when you figured out that JavaScript was not just a toy? Because I would just go to like fill out a form and I just put alert pwned as my first name or whatever, and I'd be like, JavaScript. But the moment that I knew that JavaScript was really something special, you all had this experience. You're filling out a form, you put in your phone number, and you hit tab, and the form field goes red. And you go, I don't think it posted back to the server. And you fill the form out again, and you hit tab. Maybe you pull the network cable out just to prove it to yourself. And you go, it validated the entire form on the client. And I grab my laptop, and I'm running like this, because I'm a programmer, I don't know how to run very well. And it just validated the form on the server. And my wife is like, I don't care. And then I run over and I show my boss, and he's like, I still have no idea what's happening. And I thought to myself, JavaScript is actually a thing. JavaScript's a thing that people can do amazing stuff with. So then, to prove that people could do amazing stuff, I went and found this. This is a complete implementation of Linux entirely in JavaScript. But hang on, though. You should be immediately suspicious, because anytime someone shows you something cool on the web, you have to right-click on it first to make sure it's not Flash. Because I could have just said that, and I would have right-clicked, and it'd be like, about Flash, and you'd be like, liar! You're a liar! And then even though you don't see Flash, you're still suspicious. And then you have to select the text. You go, hang on a second. And then if you're really still not even sure if that's really a thing or not, then you need to go and run GCC and then compile a C application. So now I'm running Windows, running a browser, running a JavaScript, running a Linux emulator, running GCC, and compiling a C application to say hello world, because that's awesome. And I showed this once. Is it going to work? I showed this once at a conference, and they didn't. They said, why aren't you using TCC? I don't think my choice of C compiler really affects you. I'm running JavaScript complete emulator. So I was trying to figure out how I could explain to them that this was an important time in our lives and that something amazing had just happened. And the best thing I could do to prove that was to fire up on my Windows machine an iPhone emulator and then go to Safari, and then inside Safari fire up a Linux emulator. And then so now I'm running Windows, running iPhone, running Safari, running JavaScript, running Linux, running a C application. And I think at that point, I am allowed to pick my own C compiler. So this is the part where I remind everyone that you probably should stop disabling JavaScript, because it just seems like, at least in Portland, when I meet people, before I've heard their name, I know that they're a vegan, they do CrossFit, and they disable JavaScript in their browser. And I'm literally just handshaking them. I've just now met them. I don't know your name yet. Well, you know I am a vegan CrossFitter, and I don't browse with JavaScript enabled. Why? You have to have JavaScript. All the good stuff happens when you have JavaScript enabled. There's amazing games written in JavaScript, and at this point, you might be thinking, this is probably where Scott is going to show us that you can compile C++ and run it through Clang and Emscripten and turn it into asm.js, and he'll probably run Quake in the browser, because that's the point in every talk about JavaScript where someone has to go and run Quake in the browser. No, not going to do it, because it's cliche. No. And I just like to look at Jack Reacher being sad. What I want to do instead is I want to take the characteristics of JavaScript and overlay it on that one slide that talked about the characteristics of an operating system. So JavaScript has garbage collection, it has all these great graphics subsystems, it's got networking and all this kind of stuff. It has all the characteristics that one would need when they wanted to make something an operating system. JavaScript must be an operating system. And Atwood's law says that any application that can be written in JavaScript will eventually be written in JavaScript. Then again, proving that JavaScript is its own operating system. Now, at this point, I've pretty much convinced myself of that, but then I discovered that Hanselman's law is that any application that can be written in Microsoft Excel will eventually be written in Microsoft Excel, including a pixel-perfect compatibility system of Pac-Man, where each individual cell is a pixel. This is actually so perfect and so amazing that it can't be stopped. Ooh, that's a good error. I'm going to go ahead and say yes. I love it when Windows says not responding. You know, Halloween is coming up. Have you heard about my Halloween costume? I'm going to be going as Microsoft Outlook. I'm going to set up this like a shower curtain with kind of an opaque shower curtain where you can kind of see me, but you can't quite see me, and it's going to say not responding at the top. And then I'm just going to go to parties and then just be really antisocial and refuse to speak to anyone. It's going to be amazing. So you've got a new operating system on your phone that you didn't know inside of that browser. And phones are so powerful now. This is all the stuff that I had in my pocket in 1993. And that's all the stuff in my pocket today. There's been so much creativity since the introduction of the iPhone. It's a very exciting time for phone design. Now, this young man said that betting on HTML5 was a problem. It was too soon. They should have bet on native instead, and he wrote Facebook's app over again. I think that that's wrong. I think HTML5 and the open web are going to continue to push things forward, and it's been proven that HTML apps can be as fast as native apps. There's a really wonderful quote from one of our great American philosophers that says, "The avalanche has already begun. It's too late for the pebbles to vote." What a great freaking quote. That's one of those quotes you just want to put in your mouth and chew on it. The avalanche has begun, the mountain is coming down, and the pebbles are having a meeting about the avalanche. How do we feel about this avalanche? That's your boss wondering if HTML5 is ready for prime time. Do you think that this is a thing? Is it going to be a good idea? Maybe let's wait and see. Who said that? Which of our great philosophers said that? Ambassador Kosh. Awesome. Thank you. First time that has ever happened. Big hand for the young lady for pulling that off. Thank you. Awesome. Now, when you say HTML5, you really mean JavaScript and CSS, right? It's the family of stuff. And ultimately, how do you tell HTML from HTML5? Well, you try it out in Internet Explorer. And if it didn't work, it's probably HTML5. That's the general test for HTML5 compatibility. It's difficult to be a web designer. Now, there was a time when the most advanced thing in computer science was HTML tables. There was no more complicated thing. It was compiler theory, HTML tables. And I could go in off the street to anywhere and I could get a job. Do you know tables? Yes. Yes, I do. Boom, junior engineer. Then later on in my career, they would say, do you know row span? I do. Senior engineer, VP of engineering, based entirely on HTML tables. In fact, I know that on Netscape Navigator 4, the maximum number of nested tables is 32. And the only way that you know that is when you've written your 33rd table. And you've stared Satan himself in the face and said, I don't think so, sir. I don't think so. But today, HTML is nothing. The kids don't even appreciate the angle brackets. They just make a div. I'll see the most amazing stuff. I'll see Gmail level, multi-page, cool Ajax, blah, blah, blah. And I'll go, awesome, view source. It's one div. I have no idea how they did that, but that was an amazing div. They wrote that div better than any other div. HTML is just the structure now, right? CSS gives you the color and the style, and CSS is so expressive and powerful, so intuitive. You immediately know what you're going to get when you try to express something in CSS. Completely clear and understandable. It's amazing. CSS is awesome. Now, I tried to fix this cup because it bothered me. And it's even worse when you try to fix it. You can't. So then you use JavaScript for everything else. And JavaScript is amazing because in Ruby, everything's an object. In Clojure, everything's a list. And in JavaScript, everything is a terrible, terrible mistake. Here's me learning JavaScript as a young child. And JavaScript is great because you don't even need to learn the bad parts. You know, you can think of a noun and Google it, and there is a noun.js. I was like, lawn chair. There is lawn chair.js. It is a real thing. JavaScript is so intuitive, powerful, so fun to debug. Now, John Resig, who wrote jQuery, made this amazing book called Secrets of a JavaScript Ninja. You should get this book. It's amazing. But I noticed when I bought this book that there's a samurai on the cover. So I said, John Resig, why is there a samurai on the cover of Secrets of a JavaScript Ninja? And he says, well, that's because JavaScript is loosely typed. Ninja, samurai, duck typing. I apologize for that joke. Now, someone else said once that JavaScript is the assembly language of the web. Who said that? I did. I had to be in here somewhere. I'm going to make that a quote. Everyone else said that, and I got yelled at on Reddit. So I went to Brendan Eich, who created JavaScript, and I said, what's the deal here? And that is actually Brendan Fraser. That is Brendan Eich. But, you know, Brendan Fraser's a beautiful man, so we'll just keep him up there. He needs work. I haven't seen anything of his since The Mummy. Brendan Eich says JavaScript is the x86 of the web, but he said it a couple of years ago, and he can't claim it's original. It's one of those things that everyone says, right? But then it actually happened. Like I said it, it's a new assembly language, and now they're making it. They're making the WebAssembly. It is a joint effort, and this is happening where you're going to be able to compile C and C++ in a supported way into WebAssembly, and it's super powerful. You can do things now, of course, like CoffeeScript. Like, this is what a Ruby person wishes JavaScript was. Or you can take TypeScript, which is what a C# person wishes that JavaScript was, and you can compile those things into idiomatic JavaScript. So it's a compilation target, it's a trans-compilation target. But people sometimes let layers hide too much complexity, and they don't really learn JavaScript, right? They just learn jQuery. They forget about the underneath bits. They think that they're slick, but they're not. I'll do that one again, sorry. That's just too good not to show again. I'm almost done. Now, people say that no one writes JavaScript anymore, right? They write jQuery. You can meet people and ask them to go and do some JavaScript, and they'll immediately go and say, open resig, and then they'll start writing some selector. Who said this? jQuery said this. jQuery, if you go and look up jQuery in the Wikipedia, it says jQuery, this article is about the actor for the JavaScript library, see jQuery. So jQuery actually said that no one writes JavaScript anymore, they write jQuery. And the great thing about knowing who jQuery is and knowing about his IMDb page, it's amazing, is that once you know jQuery exists, if you're having a conversation at work about it, like, we should probably use jQuery for that, then you have to say, well, I don't know, I'll call his agent and see if he's available. I've ruined jQuery for you because jQuery. Because you think you're going to build something with jQuery and it's going to be amazing, and then it never turns out the way that you thought it was going to turn out, and you don't know whose fault it is. It's extremely stressful. jQuery. People need to use VanillaJS. Know your low-level stuff, right? VanillaJS is where it's at. That is a library that I think we can all get behind. VanillaJS, Googling for VanillaJS, is this fast cross-platform framework, and you can go up here and say what you want. You can say, I want animations and regular expressions, a math library, and Ajax and DOM, and it will go and dynamically build the library that you need. And what's exciting, well, it is a little bit bigger when you gzip it. Yeah, because it turns out that you already have the stuff that you need, right? And people will go and, there's all these great frameworks available, but they'll go and they'll, make their own before they go and do their startup, right? People should expect more from their web tools. The web is in a really great place right now where stuff works well together. Things are plugging in well. So I explained to the person from Intel that you have got this amazing cloud on the server side, on the back end, this an infinite scale and elasticity and your choice of languages. But on the client side, you have this deceptively powerful accelerated machine. You've got a virtual machine you're not using. You might say, well, 1,000 people have hit our website and we only have 10 machines in the farm. But are you forgetting about the 1,000 quad processors that have JavaScript and a VM on them? It's amazing how often I'll go to a page that has a table and I'll sort by a certain column. And we all know that the Intel i7 processor isn't optimized for sorting lists of 10 or even 15 items. So we'll post those items back to the server and let the server and the cloud, the power of the cloud, sort those 10 items and then bring them back over again. I'm seeing graphs and charts being generated as PNGs on the server side while Pocket supercomputers sit and wait. So remember that you've got this integrated virtual machine, and you can write JavaScript, or you can target it with JavaScript. Your cloud doesn't need to work so hard. That's what I've got. You are powerful, my friends. You already know the cloud, and you can program the browser, so get to work. Thank you very much.